Hi, welcome to another session of the Potter's Roundtable from Washington Street Studios in Bolivar, West Virginia. I'm Phil Birnberg. Today we're going to be presenting a discussion about the construction of a gas-fired soda kiln at Washington Street Studios. And the presentation is going to be in 3 parts. Hi, this is the third and final part describing the construction of our gas-fired soda kiln at Washington Street Studios. So in the last part, we had talked about raising the chimney, and we had completed the end walls on the kiln. And we were talking about how you plan the arch, and we constructed the arch form, and we completed the chimney. We had done everything up to the point where we needed to actually add the metal framework to support the arch. So that's where we pick up the story here. So at this point, we've raised up the chimney, we've completed the chimney, and so now before we can start actually building the arch, we have to add the metal framework. So this shows our welding team starting to build the welded angle iron framework. This is 2-inch angle iron, 2-inch angle iron. And they're starting by adding the vertical at the corner and then connecting with a few horizontals. And we have several more views here. After adding some verticals, they started to connect them with horizontal ties, and we also added some angle corner braces on it. And they're starting to work, I notice, on the chimney as well as the kiln body. So again, adding some angle braces and some horizontal ties. And we've just, at this point also, you may have noticed, we have added the masonite cover onto the kiln form, the arch form, but we're still just resting that in place. So there's the completed framework on the kiln and the chimney. Now you notice in this case, remember I mentioned before how the brickwork did not connect the chimney to the kiln body, but the metal framework does for stability, because we can always cut through that later that's not a problem. So the metal framework does tie the chimney to the kiln. And we've got angle braces, and this is our bracing system, excuse me. And we also had constructed a small welded metal table that will support the burner port extensions and the burners themselves. So and we have another view of that showing a close-up view. This is the this is a freestanding table. It's not attached to the kiln, but it's a welded metal design that will support the burners on these 2 cross rails. And then right here, this is an area to support the burner port extensions, which you'll see later on. Again, this is just another view of from the left-hand side showing the completed structure. We've capped off the chimney just temporarily with a piece of metal roofing and a couple of bricks to hold it down. Anyway, showing the completed metal framework on the kiln. And the left-hand side of the chimney, again, showing the close-up diagonal braces and how it's tied in with the kiln body. There's our damper slot down here again. Now, once the metal framework is constructed, now we can actually proceed with the arch, because with a sprung arch, you need to have the walls supported, because otherwise the arch tends to spread the walls. A catenary arch transfers all the weight basically down onto the base, so you don't need to have the end walls supported. But with a sprung arch, there's still some lateral thrust because of the orientation of the arch. It would tend to spread the walls. So I have to have the walls tied or reinforced before I can build it. So now we can. So this is where we used our blue tape. Here's our arch form in place, and I laid the blue tape along the upper edge of the arch form until the marks just indicated where the bricks would touch down, so we would know how high to shim the arch form. So this was very handy at this point. And now we've actually started to lay bricks on the arch. So we have wooden shims now under the arch, holding it to the approximate correct height. And the wooden shims, actually I found work very well. I rub them with bar soap so that I don't want to use bricks down here, because the friction I found is too great and they're not as easy to knock out. So wooden shims rubbed with soap are great. You can almost push them out with your bare hands when it's time to remove them. And we've also wedged the arch form in place so that it doesn't shift around, because it had to be a loose enough fit to easily fit in the gap in the kiln. But now we've also wedged it in place so that it doesn't move. So we've started to lay bricks. These are called skew backs or skew bricks. And they used to be produced in a lot of different sizes and angle configurations, commercially, and they're not really produced or available much anymore because so much of brick construction, at least on an industrial scale, has gone to castables and spray and fiber insulation, that a lot of these standard brick shapes are no longer available. So in this case, and also there are so many different arch constructions that there are so many different styles that you could use. So we basically cut our own. So this would basically be called a skew brick or a skew back. And the idea is it's cut to just a precise length so that it will support the brick and push against the cross brace. This is how the arch is supported, is the part of the weight. When this arch is set in place, part of the weight or the force is down and part of it is sideways that it creates. So by having this brick in here that pushes against the frame, it supports that load. So these were cut individually. Once we knew where the arch form was going to set, these were cut individually to just fit that proper distance between the point of contact of the brick and the reinforcing bar on the framework. So this is showing we've cut these, and these were high heats because they are not going to be in direct contact with the atmosphere and the highest heat in the kiln. The arch itself, again, would all be super duties. So we're starting to lay some bricks on the form. And next one, this is another view. Now you can see where, in this case, we had some bricks where we had cut off a little bit of the point previously, but we could still use them. And we ended up filling this little gap with some fiber insulation. But again, showing how these push against this brace and basically support the thrust that the arch tends to create where it wants to spread the walls, and this brace prevents that from happening. So now we've laid, you can see the wood shims on both sides here. We've laid bricks up. We're starting to approach the top of the arch. And now we're doing these, we're alternating because, again, we wanted this to do the bonded arch. So even though you can't tell from this view, we've alternated full brick, half brick, full brick, half brick to give us that alternating joint pattern on the top part of the arch. And here we're getting very close to the top of the arch, and you can see the screws. These screws here are basically just holding the masonite to the cross braces in the arch support form. Now, when we finally got to the point where we were inserting the last layer of bricks in the center of the arch, we found that we wanted, when we put that last row in, we didn't want it to drop in loosely, but we also didn't want to have to hammer it in. So by using levers under both sides of the arch form, we were able to lever up the whole form and all of the bricks lying on it just enough so that the bricks slid apart a little bit and created a space for us to drop in that last low of bricks. So we didn't want it to be too loose or too tight, and I didn't want to have to pound it in because that would create stress on the kiln. So we raised it up just enough so the bricks fell apart enough to separate it. We dropped in the last row, and then we lowered the arch. So this is showing where we're lowering the arch again into place, and the form and all the bricks lying on it. We're lowering it back down, and we're removing the shims. So once the shims were removed, now we could actually hopefully remove the arch. So this is sliding out the arch form, the arch support form, and the arch. And we made it when we planned it originally so that when we shimmed it, the arch would drop about an inch or an inch and a half, so that it would even if the arch settled a little bit, it would clear it enough. Because I've seen cases where if you didn't have the arch form drop, when the arch will naturally settle. And if you don't have the arch form drum enough, it's still resting on the form and you can't get the form out. So you want to make sure that the form drops enough to completely clear the arch. So here we're removing and there's the final freestanding arch and some of our construction debris. And so the sidewalls still have to be constructed, but there's the arch, and I'm just tapping a few of the bricks, checking on them. And then the next slide, we have another view. There's another view of the final freestanding arch. And you can notice here, there are occasionally, it actually worked very well. There were a couple of bricks that dropped down in a little bit, not a lot. I don't know whether you can see the shadow there of one of them. And that's not surprising because, again, we're not using any mortar to even them out. So even the arch bricks, they're not all exactly the same size. So it's not surprising that you might have a row where if one brick was a little thinner, it might slide in a little bit further. And now you can see the bonded arch pattern very clearly on here where we've got the alternating joints. Okay, what I'm doing here is I'm tapping on some of the bricks that are protruding in a little bit. I'm tapping on them with a rubber mallet to see how loose they are. was it just sort of the sequence in which the arch dropped that they maybe fell in, and could I just push them back out a little bit? Or were they loose enough where we were going to have to actually maybe shim them or wedge them in place a little bit? And we did do, and so now we're going to, and we'll come back to that when in terms of shimming the bricks. But now we're going to start to think about constructing. If the arch is done, we're going to start to finishing the two side walls. So this is the right side wall of the kiln. The burners are two. There's our, down at the very bottom, you can see there's our old thermocouple tube. And so again, the point I'm making with this slide is the fact that for this part of the arch, the inner layer of the wall will tuck up underneath the arch, and the outer layer of the wall will come up against the face of it. So that way we don't have a joint that goes straight through from the inside of the kiln out. This will tuck under, and this will cover the face. And you'll see that again when we further on. So in order to fit the bricks under the arch, we would need to cut shapes. If we wanted, ideally, if we wanted to build up that inner layer, we'd love to be able to cut shapes like this that would fit the curve of the arch. But with the particular brick saw that we had, we couldn't make 4.5 inch deep cuts with our brick saw. So the trick that we used was we cut the bricks, we take a brick first lengthwise and cut it into essentially a soap. Then we could turn these sideways and cut these at any angle that we wanted to, and then just put them back together to fit under the arch. So it enabled us to make any angle cut we wanted to fit under the arch. So this is looking through the door of the kiln. There's our old thermocouple protection tube right there as a locator. And this is showing how, this is the right inside wall showing how we cut the bricks to fit underneath the arch. So these are tucked in underneath the arch. And we have another view that shows the close-up of how some of the triangular and angular shapes we cut to fit underneath the arch. And you notice here's the inch setback. This is the end of the arch, and so this is that inch I mentioned earlier, so that the arch is starting to rest on the end wall an inch back from the actual inside face of the wall. And now, at this point, we decided to see what we could do about fixing some of the bricks that were hanging. So we made up a really thick slip out of a very coarse fire clay. This is Mount Savage Fire Brick Company fire clay. It's the same fire clay they use to make their bricks, and some OM4 ball clay. And it's a really gritty, groggy kind of fire clay, but we're going to basically use it as to fill the cracks on the bricks. So what we did was we'd take a brick that was hanging down, and we'd tap it back out a little bit so that it was actually recessed on the inside of the kiln. And then we'd pour the slip over the end of the brick on the outside of the arch, and it would run down into the gap, and then we'd tap the brick, push the brick back down in place. And this worked very, very well to take up that little extra space and reseat the brick. So we did this in several cases where none of the bricks were hanging down more than, I'd say, 1/4 inch, but we wanted to reseat them so that we had a smoother inside surface. So now this is showing, again, the right outside wall. Here's our inside wall fit underneath the arch, and the outside wall will just cover it. So this is showing where we started to now these are some other bricks that we had. These were 3-inch thick bricks that we just happened to have, and this was the perfect place to use them. These are high heat bricks, but they're 3 inches thick because they don't have to interlock with any of the other bricks. So the fact that they're a slightly different size didn't matter. So it was a good place to use them. And it's actually nice because then the joints don't line up. So we actually get a better seal. So we started to just stack them up over the face of the arch. And I think we have another view, yep, and there's the final view showing, this is the right-hand side of the kiln with the outside side wall completed. We've actually used the same slip to cover the surface of the arch because we had some extra slip left over. And even though the bricks at this point were all sitting very nicely, because this is going to be a soda kiln and there are going to be vapors coming out, we thought it'd be a good idea if we could to seal the arch. So we just covered the surface of the arch with that same slip. And we used a nice brush. We have a picture of a brush here, I think. Yeah, this is a wallpaper smoothing brush that we used to spread. It worked very nicely to spread that slip. We didn't want to actually build up a layer. We just wanted to work it into the joints so that it would seal the joints. So we used that to spread the slip. So I guess now, so this is, so then on top of once we had done that, on top of the dried slip, we put down 2 layers of insulating blanket. This was basically Fiberfrax blanket I think I've got it was inch-thick blanket. This was Unifrax Dura Blanket S, as in Sam, 6-pound cubic density. So we put down this was also material that we salvaged from the previous kiln. We put down 2 layers of blanket, and then we covered it with a layer of welded fencing. These are 2-inch by 4-inch openings for scale. And that's just to hold the blanket in place, basically. And then we anchored the blanket and the fencing with an extra layer of bricks on the end. And I think we have a view over the door opening here also. Well, this is another side view, and this is black, again, just because that was salvaged from the previous kiln. It's just a little soot where it was over the door in the previous kiln. And then this is a view showing the 2 layers of blanket over the door opening, and you can see a little bit of the fence above it. It just holds the blanket in place. So now we've completed the arch, basically the top of the arch. I covered over the blanket with a tarp. I found is very handy because otherwise birds like to pick at the blanket and they'll build their nests out of it, or they line their nests with it. So we put a piece of tarp over it just to keep the birds away. So now we've completed the right-hand side wall, and we need to build up the left-hand side wall, which is basically the door frame. So this is showing the same idea that the inside layer of the door frame will fit underneath the arch, and the outside layer of the door will cover the arch. We put, in preparation for our first test fire, we put a stack of shelves in here with some cones where we're going to map the kiln. And this is showing the completed door frame for the kiln. Again, inside layer under and the outside layer over. One of the points to make here is because we're making the door out of brick, 5 bricks wide, it was very important when we were building the wall to make sure that these walls stayed vertical, so that even though it was 5 bricks wide at the bottom down here, it stayed 5 bricks wide plus a little bit at the top. So it's very important not only to check the horizontal level of the bricks, but check the verticality, make sure the wall didn't start to encroach on the door as we were raising the door walls. Now we've built so basically the body of the kiln is complete at this point. So now we've added the 2 burner port extensions. These were constructed basically just with K23 bricks, so they're 9 inches long. So this is a 9-inch long tunnel supported on the table in front of the burner. And we've just snugged it up. There's nothing holding it in place. It's just sitting there snugged up against the front wall of the kiln. So there are the plugs in our 2 soda ports and our shelves and the burner port extensions, and then the burner ports will go up against those. And again, the idea of those burner port extensions was just to give us some additional distance and additional time for the gas and the air to mix before they get into the kiln, and would also help create a condition where we'd probably get a lot of turbulence in those tunnels, which would give us better mixing. And then as far as the gas supply, we already had 2 100-gallon propane tanks on site that we had accumulated or set up for this kiln, also in anticipation of building one. So we had a pre-existing T in the line, so we added another shutoff valve, and we added 2 separate secondary regulators to the kiln. Instead of having 1 regulator, again, I've run into situations where during a firing, if something happened to one burner, let's say you started to get carbon deposition on a burner, or one burner starts to have problems, you might need to make adjustments to the one burner. You might want to change the pressure, for example. Well, if you only have 1 regulator, you can't do that. So I know this is a little bit of a luxury, but we wanted this to be a Cadillac kiln. So we decided to have separate regulators, 1 for each burner, so that again, we'd have complete flexibility in terms of adjusting the burners. So this is all black iron piping with the 2 regulators. Now with a gas kiln, remember you have a primary regulator at the gas tank, which establishes the line pressure, that is the pressure in the gas pipe coming from the tank to the kiln. And then close to the kiln, you have a secondary regulator, which drops that pressure down to what's actually the working pressure that you're going to use for the burners. And you want to be able to adjust that, because during the firing, you might find out that you need to raise the pressure on the burners a little bit to get a little more gas flow. So then in this case, now we've got the pipe, now we've connected with flexible propane hoses to go to the burners. And we have a view here that's showing the hoses coming in. Now that we've got the burners clamped with C-clamps to those 2 cross rails, and we've got the flexible metal hoses connected to them. We've set another silicon carbide shelf on top of the extensions as another shield partially because so that when people are spraying into the soda ports, they're a little more protected from the flames and the burner. But again, it also helps the bricks for the burner port extension are not very heavy by themselves, so it provides additional weight to hold them in place. And this is just a close-up view. With this arrangement with the C-clamps, we wanted to be able to slide the burners in and out so that when we close off the burner ports, we can pull them back and put some kind of block or barricade or shelf or something in front of it to completely close off the burner ports. But we wanted them held securely enough in place during the firing that there weren't any safety issues. So with the C-clamps and the cross rails, this arrangement works very nicely. So now we're going to start to construct, to show the door. And again, this is just showing the orientation of the bricks. There'll be basically a header course in the door frame. So we're starting to insert bricks, and the door frame again was planned so that the bricks just have just barely enough room to sort of slide into 5 bricks. These are some pots that we put into the kiln for our first test firing. And we figured that to cut that little bit of extra space that we're allowing to be able to fit the bricks in place could either be closed up by just tilting the bricks at a slight angle, showing such as this, where we just close them a little bit, or later on we could also insert small pieces of insulating blanket, push those into the cracks to seal the brack. I personally don't like to use the mud as a door sealant because I found it usually cracks anyway, and it's a mess. And this I found, as long as the kiln is fairly well built and fairly tight, this works just fine in terms of just using it with brick wedges or insulating blanket. So now as we approach the height of our, in this case we only had one cone pack we were going to watch through the door. So as we're approaching the height of the cone pack, we need to start constructing a viewport in the door. And the viewport was constructed, it's just a single brick opening, and it's constructed by crossing it with 2 bricks and then using 2 soaps to make up the distance. So now I'd still be able to fit bricks in here. So the brick and the 2 soaps gives us the span that we need for the viewport. And I can use just a half brick as a plug. So again, because on the one hand, these bricks are hard to work with because they're not all the same size. But on the other hand, a nice feature of the fact that they aren't all the same size is that I can just look around and find a brick that's slightly thinner and use that for a plug. So now we've gotten the door up to the point, and I've also, when we were stacking the door, we have it protruding from the face of the wall of the kiln about a ½ an inch, just to make it a little easier to handle, to move the bricks around. And now we've raised the bricks to the point where we can't fit another brick underneath the arch. So now we have to start fitting the bricks to the arch. So we have a view here showing how we would cut a brick to approximately fit underneath, because remember the inside wall of the arch of the door is going to fit underneath the arch. So this is just showing how we could fit a piece underneath the arch. And this is only a soap, because again, I can't cut these bricks full width. So this is basically a soap cut to fit underneath the arch. So then there's that same piece. So then what we would do is we'd do a wall of basically half brick widths and other pieces and chips, and we'd fill this in basically, and then we'd fill in the extra space with insulating blankets. So now we've built that inside wall out all the way to the face of the brick, combination of pieces of brick, insulating blanket, and plug it. And we purposely didn't worry about making this a precise fit because the kiln with time is going to settle, and the bricks are going to warp and change. And we may change bricks in the door with time. So there's no guarantee that those bricks are always going to be the same size. So this way, we're going to have to reconstruct the top of that door every time to make sure it fits snugly. And that's not surprising because the bricks will change and that space will change with time. So now we're building up the outside wall of the kiln, and I think we have one more view. Do we have another view? Yeah, where we finished the door. Now the door has been built up to the full height. There's the edge of the door right there with our one viewpoint brick sticking out. And so that's the completed door. And so here are some final kiln dimensions that we had just for information. Overall, the kiln was approximately 4 feet wide and 8 feet long, including the chimney. The height to the top of the arch was 6 feet 3 inches. And the sprung arch dimensions, the span was 47 inches. That's what I mentioned. The distance between the 2 end walls was 45, so the span was 47. Means it was sitting back an inch on each end. The rise was 14 inches, and the width was 36 inches, so it was 4 bricks wide. Last time I said 3 and I was corrected. So it was 4 bricks wide. The chimney was 11 feet tall on a 1.5 foot base, so the total height of the chimney from the ground was 12.5 feet tall. Total internal volume we calculated to be about 28.6 cubic feet. And after the bag wall, the wear chamber, now again, we haven't worked out the final location or the design for the bag wall yet at this point. So approximately the volume of the wear chamber is going to be around 20 cubic feet. Well, we hope that this discussion has been useful today for you, and we know that this was a lot of information probably presented in one time, but if you'd like to hear it again, you can listen to our podcast version of this presentation. Just look for the Potter's Roundtable on your favorite podcast platform. Thank you very much for joining us today and seeing this. We hope it was useful information, and thank you for visiting with us.